All right, let's go to chapter 4 of the CompTIA Linux Plus preparation course. So what we're going to do today is we're going to cover permissions and ownership. And this is something that CompTIA loves to question about. This is one of those sections that if you don't understand, watch it more than one time. Go through this section multiple times. Go through the labs multiple times if you need to. This section is unique. And you do need to fully understand this in order to be, for one, a great system administrator, and for two, to pass the CompTIA Linux Plus certification. This is a section that I've noticed many students have issues with in the past, and I do highly recommend to spend some extra time and care on this section. All right. So, by the end of this chapter, you're going to read and understand the Linux permission model. It is unique, it is different, and it is numerical. And so for those who don't like numbers, I am sorry, you're not getting away from it. We're going to learn how to modify files and directory permissions. We're going to figure out how to create ownership on directories and files. We're going to talk about some special permissions that you need to understand on Linux. And then how to troubleshoot some common permission denied issues. All right, just like my analogy before, creating users is like handing out ID badges. But setting those permissions is determining which doors those badges can open. So if we don't set up properly, our users will be able to open up any doors, including doors they're not supposed to. And remember, we are trying to enforce the privilege of least privilege permissions. Okay, the principle of least privilege. And if you don't do that, then you're going to create problems for yourself down the road. Whether or not you have malicious insiders, or if a threat actor themselves gets access to a certain account, you don't want them to be able to access anything and everything on a system and change anything and everything on a system. Okay, so we need to understand how permissions are set because we want to make sure that we control what users are allowed to do on our system. Now, there's going to be two core concepts that we're going to be talking about. The first one is ownership. While everything on a Linux file system is a file, we need to know who it belongs to. There's always going to be a user and a group that every file on a system belongs to. Now, even if we know the owner, what permissions do they have, and who else has access to this file as well? And we'll talk about how that's split up. So let's talk about ownership. Every file and directory has two owners. There's a user owner, the individual user account that owns the file. By default, this is a user who creates it. Okay? So if you touch a file and you do an ls-l, you will notice that you own that file. But if you sudo touch the file, you didn't run that file. You ran it as root. So root will own the file. Do the same thing when you look at the group. The group owner, on the other hand, allows you to tell, well, what team can manage this? What group is allowed to manage this file and at what permissions? Maybe the owner has certain permission and the group has a whole different set of permissions. It all depends on what you're trying to accomplish. So there's three basic permissions in Linux. There's read, where you can view all the contents. There's write, where you can modify or delete. And there's execute. Execute, think of this like when you're trying to run a program or a script. Are they allowed to run this as a compiled script? If so, they will have the execute permissions. And how do we decode this? Well, one of the easiest way that we've seen this in the past is by running the ls-l command. Remember, this is the long form of the listing command. When we look at this, we see a whole bunch of information, but today what we're trying to focus on is what we see in yellow, the very beginning of this line. We're going to be looking at this 10-character string of permissions. And this is what's going to tell us what permissions are set on myscript.sh, the file at hand. The first section of it is the file type. If If you just see a dash, it's just a file. There's nothing special about this. But there are a couple others that you'll see with it. For instance, a D. D tells you it's a directory. This is a folder. Or an L. This is a link. Think of it like a shortcut. Symbolic links are shortcuts. They're not the file itself. They link you to the actual file. There are times where we might want to give access to a symbolic link and not the file itself. And each one may have different permissions. So if we decipher the second half of this, the other 9 characters, we can split it out into 3 character groups. The first 3 characters is always the user, the owner of this file. The second 3 is the group. And then if you're not one of those, what about everyone else? Anyone else on the system, what access do they have? Okay. Now if we took at this example and we decoded a little bit, it had a dash. So it's just a regular file. If we look at what the user can do, they're allowed to read, they can write, and they can execute this file. The groups, on the other hand, can read and execute, but if you notice, they don't have the write privilege. There's a dash there. And what about everyone else? They're allowed to read this file, but they can't write or execute this file. Okay, remember this is a shell script, so not being able to execute a shell script makes it where I can't run the file. But if I was the group, I can write it, I can run it, and then if I'm the owner, I can also modify that script, but nobody else can. Here is it broken down a little bit different. R for read, I can view all the contents. I can list the file names and any files inside of it. Write, I can modify, but in a directory, can I create, delete, or rename files within it? And then execute, can I run this program? Or can I run even a command on this directory? So depending on if we're talking about a file or directory, is depending on what I'm allowed to do. So keep an eye on that. If I'm dealing with a file, I'm talking about the file itself. If I'm talking about a directory, I'm talking about the directory. So can I run commands within the directory? Can I create files within the directory? Can I list? What can I do? Now the first command that we're going to talk about is called changemod. So changemod is a command that we use to change permissions. And it can be used in 2 different ways. We can use symbolic mode by using letters. It's very intuitive, easy to read. Or we can use octal mode, which is using numbers. So if we look at this, octal mode means 0 through 7, means there's 8 values that can be. It's very fast, concise, and I like this mode because it's very efficient. Now using symbolic mode, you have to be able to say, am I making changes to the user, the group, the other group, or every one of them? A for all. So you've got to pick one. Okay? So if I wanted just to make changes to the owner, the user, it would be U. But if I want to make changes to the group, it'd be G. Now if I want to add or subtract a action, then I would write that. So for instance, let's say I want to give the user all privileges. It'd be U plus, actually U equals RWX. Because I can set exactly the permission that I want. But if I only wanted to add write, it could be U plus W. So using symbolic mode is pretty easy, but it is not the way that you'll notice on the exams what they like to test on. They love to test about octal. You do need to know symbolic mode as you move through here, but also keep in mind that you need to know octal mode as well. So here's some examples. The first one, I'm adding execute permissions to the user. The second one, I'm removing write permissions from the group. And the third one, I have users and groups, and I'm adding read and write. And then other, I'm giving nothing. As you can see, this can get kind of complicated very fast when you're doing this. 9 times out of 10, you'll notice symbolic mode gets used quite a bit for the users who are just making a single change. They're adding execute, removing execute, just adding a single or removing a single privilege. If you get to the point where you're modifying the entire permission string, like the last one, I highly recommend using octal. It's way shorter and easier to remember. So as we're doing the numeric mode, the octal mode, we have 3 different values, right? We have read, we have write, and we have execute. What we do is we assign a value to each one of these. Read is a value of 4, write is a value of 2, and execute is a value of 1. Now if we add them all together, that is going to be the privilege. For instance, if I say they have the privilege of 3, you would look at this and say, well, that would be write and execute, but they would not have read permissions. If I said 7, you would say, well, they have read, write, and execute. If I said 6, they would have read and write, but not execute. If I said 5, it would be read and execute only, and not write. It's pretty easy to go through this and actually see what that looks like. And here's the octal math again. Read, write, and execute, 7. Read, write with not execute, 6. Read and execute, 5. And read only would be 4. So as you can see here, we can easily add different permissions into things. Normally we don't see anything below a 4, just because you cannot write or execute to something that you don't have read privileges normally. And I say that normally because there are special cases where you may only want to give them write privileges but no read or execute privilege. There are ways to do this within the software. There are a lot of times where we have banking systems that are locked down even tighter, where they won't even let you see what's in a file or won't let you see what's in a directory for security purposes. So here's that octal mode with some examples. So if I wanted to write, give owner full privileges but give everyone else read and execute only, change mod 755. Pretty common for scripts. You'll notice this quite a bit. Now, if I want to give read write and read to everybody else, 644, pretty common for text files, yeah. And if I want full privileges and give nobody else privileges, I can do 700. But be aware, even if I have no privileges to a file, who can access every file on the system? That is right, root. So if you have other users that know the file exists and they can log in as root, just be aware they also have privileges to these files. Now they're going to be accessing it as root and not as their user, but we have to be very cautious on who can do things. Now if we want to change the owner of a file, let's say I created a file and I wanted to give you the file. What I can do is I can chown the file. I can change owner. Now when I change owner of a file, I can go from one person to another. Now with this in mind, to change ownership of a file, we do need to use sudo. Sudo is the root admin privilege, and in order to change the owner from one to another, I need to run that as a root user. Here's an example from changing this user. Sudo chown bwayne in the group of heroes of remote.txt. Basically, I can change the user and the group on a file all in one command. If I only wanted to change the user itself, I would just say bwayne for Bruce Wayne of report.txt. If I wanted just to change the group, you'll notice the colon at the beginning. I'd say colon heroes. The colon denotes what part am I changing. I can only change the user or the group, and so I need to tell the system which one I'm changing. By putting a colon in it, I can change one or all the variables of a file. Something of note, if you are asked on the CompTIA Linux Plus, you can use wildcards here. So if I want to change owner of everything in a directory, I can use an asterisk here as a wildcard. If I just wanted to change all text files, I could do asterisk.txt, and that would change all text files in this directory. The other methodology that you can use here is you can use the recursive flag. Capital R is for recursive. This flag is very powerful, and it's normally used on directories. Just be aware, everything from that directory down is now going to be changed owner. We utilize this quite often when we're dealing with our servers. Not only are we changing it for users, we may also change this for services. For instance, if I'm trying to host a web server, I will want to make sure that the web server has access to all their files and nothing else. By changing the owner to www, I can make sure that www has the proper permissions to those files. It's another way that we can also make sure that if a file or directory does change, we can change owner. For example, if Bruce Wayne does leave the company, I can change ownership of his files to somebody else within a single command using the chown directory. Now, getting beyond the standard 10 characters that you see, there are things called special permissions. And this is where it starts getting confusing. The beginning part of here is pretty simple, pretty easy to follow, but special permissions are one of these things that is almost an afterthought when it comes to Linux permissions. Okay, and so we have to make sure that we keep them straight in our head. We now know of the 10-digit permissions, but there's also a special permission character at the very end that you normally don't see. It's kind of hidden. And so there's a couple of different special permissions we can add to a file or a directory. Now we got to use these very cautiously. These can mess things up quickly and it's hard to troubleshoot, okay? But if for some reason we want to run a file as owner, so we want everybody else to be able to run this file as the owner, then we can run the set user ID. So even if I run a file that you own and you have suid put on the file, then I can run this file as you. Just be aware, it's pretty easy to also break the system with this, as I am now running this file as you and have all privileges in the system as you. Now, if you wanted to set up the SGID, the group ID instead, then you can do that as well. Just be aware, whatever permission is set to that group and that group ownership, now I can run everything as that group and that group ownership. If, for instance, this is running as the accounting group and I find a way to escape that file, I can run anything as the accounting group on that server. Lastly, we can have what's called a sticky bit assigned as well, and I'll talk about that here in a minute. So suid, run the permissions as if I was the file owner. So if I have a suid bit assigned to the shadow file, I can then execute it there. You can see this because there's a special bit where it would say execute. So if you see an S in the user's execution spot, this bit has been set, and now anyone can run as the file owner. Same as it goes for the group ID, you'll see an S sitting in the group ID spot. And then lastly, the sticky bit. The sticky bit is one of the weirdest bits we have in Linux. It is basically says that nobody can delete the files except unless they own the file. So let's say I set the file directory to 777. And I set a sticky bit on there. The last bit will show up as a T. This is the other execution spot. And a great example of this is exactly that, using the temp directory. The temp directory is normally owned by everybody. But if I don't want somebody deleting my temporary file, I can put a sticky bit on it. And my analogy on this is like licking it. I licked my food so nobody else would touch it. I am now adding my sticky bit onto a file so nobody else has the ability to touch my files, to delete my file. Just be aware that all other permissions stay. There are going to be times where you want this out there. Maybe you want people to be able to edit a file or do things to a file, but you don't want somebody to accidentally delete the file. So you can go in and put a sticky bit on it, and then you will be the only one that can delete said file. So how do you set these permissions? Well, change mod, you can use symbolic or octal. And the way to do this is you can do it through the S bit for symbolic. So change mod group plus special on serve data, or you can use a fourth bit in here by setting a 4, a 2, or a 1. By putting a 4, it'd be the user. By putting a 2, it's the group, and putting a 1, it's a sticky. Okay. Now, troubleshooting some of this can be unique. If you do get permission denied, it's not a bug. It's just the security model working. So sometimes you'll have to figure out, well, why don't I have permissions to a file? And should I have permissions to that file? So if you get a permission denied, take a look. For one, who are you? Run ID. Are you running as the user you thought you were? Are you even in that group that can access that file? Do you need certain permissions to do what you're trying to do? Maybe you only have read and you're trying to write to the file. Also, run a quick ls-l. Depending on what you see is depending on what right you have. A lot of times when I see this, it's because you thought there was a certain permission on there that's not currently there. A lot of security software requires certain permissions to be set in order for files to work, especially when it deals with encryption and certificates. So there are times where you'll notice that maybe only certain people have access to read. For instance, only root access can read certain certificates to protect the user's private keys or other encryption algorithms themselves. And then lastly, how about you check that directory's permissions as well? This is something that I've noticed almost everyone forgets. You may have full permissions on a file, but if you don't have execute permission on the parent directory, you still can't get to it. How do you CD into a directory if you can't get in there? So you should have execute permissions as other into a directory in order to see it. Now, if for some reason they don't want you to be in there, maybe they only want root user to be in there, just take a look. ls-l, if you're not in the user or the group field and you're running as other and you need to get in there, well, do you have sudo access? Is that the way they design this? Or do you need to get added to a group? What needs to happen to get you access? The directory permission also will let you know whether or not can you run CD on that directory? Can you run ls on that directory? If I give other no access to that directory and you do an ls, you're not going to get anything back. It's going to look like it's empty, even though the directory probably isn't. So be careful when you're dealing with permissions in Linux, because they are very secure, very powerful, and very simple, but at the same time are very easy things to mess up. All right, today we talked about user ownerships and group ownerships, permissions for all the groups. We learned how to change the permissions, either symbolic or octal, so know both of those. We learned ownership of each files. We learned special permissions, such as user, groups, and sticky bits. Remember 421. And then we also learned a little bit about troubleshooting access denied methodology. All right. Well, if you have any questions, let me know. Good luck on this chapter. And remember, if you need to go through it a few times or play around in the lab some more, do so. So that way you fully understand what's going on with symbolic permissions, special permissions, octal, all of them. Okay? I will see you for chapter 5. Thanks.